Hey guys, welcome back to chapter 16. What we're going to talk about now is acids and bases. So we're going to take the same path that we just took through acids, talking about strong ones and then weak, and then looking at the equilibrium constant values. So strong acids, not as easy to memorize. Strong acids, so there's more on the list. But if you can memorize this general rule, you'll get it right most of the time. So all of the group 1 and some of the group 2 metals attached to hydroxide will make them a strong base. So sodium, lithium, potassium, rubidium, just going straight down that group 1 metal list attached to hydroxide. And then group 2 metals, we'll see calcium, strontium, and barium are all strong bases as well. For strong acids, for strong bases, you may need to look for some extra information. So whether I tell you in the problem or you're looking at the Ka value, you may need to just do a little extra research just to solidify if it's a strong acid or a strong base or a weak base. Okay. Weak bases partially dissociate just like weak acids. So they partially dissociate by equilibrium and they form the hydroxide ion. So bases are not always as easy to identify. But once you get the correct formula onto the paper, you will see that hydroxide ion as a product. So our ammonia was an example of where NH3 doesn't jump off the paper as a weak base to me. But once I write it in its balanced formula, I do see that appearance of the OH created. Okay. So in this case, we do see that ammonia will dissociate in solution, and it will create some of the hydroxide, just not very much of it. Okay. Same thing is true here with our K values. So first and foremost, here we see again our generic formula, and sometimes this generic formula really messes with your brain. So just make sure you sit with it, look at it, get to know it. So here we see our B is our generic form for base. So B stands for base. We put it into water. Bases are proton acceptors. So our base will always add that additional proton. So that's what we see the BH over here. It added the proton. And then our water here is acting as an acid, so it's a proton donor. So when it gives away that proton, that's where we get that OH minus coming out. Okay. Here we're going to be talking about Kb values. So subscript B stands for base. So if the Kb value is greater than 1, it's going to completely dissociate. Products are favored. That would be a strong base. If the Kv if the Kv value is less than 1, again, that's going to be a weak base. We're going to see partial dissociation for that particular compound. When we were looking at acids, remember I said we were going to monitor for an acid. We're monitoring the proton or hydronium concentration. For bases, we're going to monitor the hydroxide concentration. So that's going to be the value that we ultimately will solve for in order to quantify these bases. Okay. So that's it for strong acids, strong bases, weak bases. It's pretty much a review from the acid one. Moving forward, we're going to start to look at how we quantify acids and bases. So once we look at the concentration of the hydronium or the concentration of the hydroxide, how do we put a number on that? And something like pH, so it should sound familiar. So I hope you guys found this helpful.